Welcome back to Cosmos in a Pod's Space and Astronomy series. Today we're going to be taking a deep dive into something pretty incredible.
Oh, yeah.
Sagittarius A.
Yeah, Sagittarius A, the supermassive black hole at the center of our galaxy.
The center of our galaxy. Isn't that wild? Like, here we are on this tiny little planet orbiting a pretty average star.
Right.
And yet at the heart of it all is this monster of gravity, millions of times heavier than our sun.
Yeah, it's mind-boggling how massive it is.
And for a long time, we didn't even know it was there.
Yeah.
So how did we uncover this hidden giant? I mean, you can't just point a telescope at a black hole and see it.
Right, well, that's where radio astronomy comes into play, because it lets us see the universe not in light, but in radio waves.
Okay.
And that's how Sagittarius A was first detected.
Wow.
Astronomers picked up this super strong radio signal coming from the galactic center, and that's a region already packed with stars and gas and dust clouds.
It's like finding a needle in a cosmic haystack.
It really is.
Yeah.
So they named this mysterious source Sagittarius A, and it became a prime target for further investigation.
But how did they know it was a black hole? Was it just the radio signal itself?
Not quite. It took decades more observations to confirm what it really was. Astronomers started tracking the movement of stars orbiting super close to this invisible source.
Oh, wow.
And what they saw was amazing. These stars were whipping around at ridiculous speeds, millions of kilometers per hour.
It's like a cosmic demolition derby.
It is, and the only way those speeds were possible is if there was an incredibly massive and compact object exerting this huge gravitational pull, and that's a supermassive black hole.
So we're basically using these stars as like cosmic speedometers
Yeah,
to
exactly.
figure out how massive this thing is.
And then in 2022, we got the clincher,
Okay.
the Event Horizon Telescope,
Yes.
which is this network of radio telescopes all around the globe,
Yeah.
captured the very first image of Sagittarius A.
Wait, an actual image. I thought black holes were invisible.
You can't see the black hole itself, no, because light can't escape it.
Yeah.
But what the Event Horizon Telescope captured was the black hole's shadow.
Okay.
So you've got this dark silhouette surrounded by this glowing ring of gas and dust
Wow.
that's being warped and accelerated by the immense gravity. It was groundbreaking, confirmed decades of theoretical work,
Yeah.
and gave us this glimpse into one of the most extreme environments in the universe.
It's incredible. So we have this supermassive black hole, Sagittarius A, lurking at the center of our galaxy. Besides the obvious, black hole thing,
Yeah.
what else makes it so unique?
Well, one of the most interesting things about Sagittarius A is that it's surprisingly quiet.
Quiet.
Yeah, compared to other supermassive black holes in other galaxies. It's not gobbling up matter as aggressively.
So it's not a cosmic vacuum cleaner.
No, not exactly. It does have these occasional bursts of activity. We call them flares, where we see these spikes in X-ray and infrared radiation.
Oh, yeah.
It's like it's snacking on a gas cloud or an unlucky star that wanders too close.
So it's more like a cosmic cat just kind of playing with its food?
Yeah, that's a good analogy. But even though it's pretty calm right now, Sagittarius A still has a big influence on everything around it.
So what's it like in the neighborhood of Sagittarius A? Is it just a vast, empty expanse?
Oh, no, not at all. The galactic center is like this bustling metropolis of celestial objects.
Oh, wow.
Yeah. It's full of stars and gas clouds and dust, all swirling around Sagittarius A at insane speeds.
So a bit chaotic.
Oh, yeah. Imagine a cosmic traffic jam with massive stars just whizzing by you at millions of kilometers per hour.
I think I'll stick to Earth traffic.
Probably a good idea.
So how does Sagittarius A fit into all of this? Like, what's its role in all this cosmic chaos?
Think of it as the conductor of a grand galactic orchestra.
Okay.
Its immense gravity is kind of like a stabilizing force, keeping the whole galactic center from flying apart. It also plays this crucial role in the life and death of stars.
Wait a minute. How does a black hole influence stars being born and dying? I thought they were just destroyers, just sucking things in.
That's a common misconception. They do have that reputation, but they can also act like cosmic gardeners.
Cosmic gardeners. What do you mean?
Well, so you have these powerful outflows of energy and radiation from Sagittarius A,
Way.
and they can actually trigger new stars to form.
Really?
Yeah, because when those outflows slam into nearby gas clouds, it compresses them and causes them to collapse under their own gravity.
Wow.
And then, boom, new stars are born.
So it's like destruction leading to creation.
Exactly. But it gets even more interesting because Sagittarius A can also suppress star formation.
Really?
Yeah. In some regions, the intense radiation can heat up surrounding gas, making it too diffuse to collapse and form stars.
So it's like a cosmic double agent.
You could say that. It's amazing how something so powerful can have such diverse effects on its surroundings.
It really is.
Yeah.
But with all this activity going on, how do scientists even study it? It's incredibly far away.
Huh.
And we've established that it's pretty difficult to see directly.
Yeah, that's a great point. It's like trying to study a firefly in the middle of a fireworks display.
Right. But astronomers have these incredible tools and techniques to help them overcome these obstacles. Well, I'm all ears. What's in their cosmic toolkit?
Well, one of their most powerful tools is radio astronomy, which, like we talked about before, lets us see through all that dust and gas that blocks our view of the galactic center.
Right, like cosmic X-ray vision. Yeah. But how do they actually use radio waves to study something as, well, invisible as a black hole?
Okay, so imagine you're trying to study a lighthouse that's really far away. You can't actually see the light itself, because it's too far.
Yeah.
But you can see the beam of light as it sweeps across the horizon.
Right, yeah.
So in a similar way, astronomers can't see Sagittarius A directly, but they can study the radio waves coming from the hot gas and dust that are swirling around it.
So it's like they're watching the swirling patterns to track the black hole's movements.
Exactly. And to get the clearest view possible, they use a technique called VLBI.
VLBI.
Yeah, very long baseline interferometry.
Okay.
And that involves combining data from lots of different radio telescopes around the world.
Wow.
Creating a virtual telescope that has the resolution of a single dish that's thousands of kilometers wide.
So it's a real team effort?
It is.
But radio waves aren't the only tool in their arsenal, right?
Right. Astronomers also use infrared and X-ray telescopes.
Okay.
Infrared light can penetrate dust better than visible light.
Right.
So it gives us a clearer view of the galactic center.
Okay.
And then X-ray telescopes are really good at observing high-energy processes.
Right.
Like those flares we talked about that happen around black holes.
So it's like we're using all these different senses to study Sagittarius A.
Yeah.
We're listening with radio waves, peering through the dust with infrared, and then capturing the high-energy action with X-rays.
Exactly.
It's incredible how much we can learn using all these different methods.
Yeah, and it's not just about observing the black hole itself either. Remember those stars that are orbiting Sagittarius A?
You mean the ones we're using as like cosmic speedometers?
Exactly. By tracking their movements super carefully over time, astronomers can actually calculate the mass of Sagittarius A.
Wow.
With incredible precision.
That's amazing.
It really is. It's like this cosmic ballet. And the stars are the dancers, and they're revealing the invisible choreographer at the center.
I love that analogy.
Yeah.
Okay, so we've got these amazing tools and techniques for studying Sagittarius A, but what about the big picture questions?
Yeah.
What are some of the mysteries that are still stumping astronomers?
Well, one of the biggest ones is, why is Sagittarius A so quiet?
Right. It's like this giant monster that's just, snacking instead of devouring everything in sight.
Exactly.
So what are some of the theories about why that is?
Well, one possibility is that the magnetic fields around Sagittarius A are kind of acting like a barrier,
Okay.
preventing matter from falling in directly.
So it's like a cosmic traffic cop,
Yeah, exactly.
directing traffic away from the black hole's hungry mouth.
Yeah, so it's not that Sagittarius A isn't hungry, it's just that the food can't reach its plate.
That's a great way to put it.
Thanks.
Are there any other theories?
Yeah, another possibility is that the material around Sagittarius A is just too spread out to effectively fuel its growth.
So it's like trying to build a campfire with just like a few twigs and leaves scattered around.
Exactly.
You need a big pile of fuel to get it going.
Right, it's a supply and demand issue.
Interesting. Any other ideas?
Yeah, there's also the possibility that Sagittarius A just goes through cycles of activity,
Like,
with periods of intense feeding, followed by quieter periods of digestion.
so we could just be catching it during a downtime.
Exactly.
Like a cosmic snake that's just swallowed a really big meal.
Exactly.
And who knows, maybe sometime in the future, it'll wake up with a roar and start devouring matter and spewing out these huge jets of energy.
Yeah, that would be something to see.
But speaking of mysteries, what about the origins of Sagittarius A?
Oh, yeah.
How did this supermassive black hole even form in the first place?
Well, that's one of the biggest questions in astrophysics. And just like most things about black holes, the answer is still a mystery.
Of course it is.
But there are a few leading theories, each with their own intriguing possibilities.
Okay, I'm ready for a cosmic history lesson. Tell me about some of these theories.
All right. So one of the popular theories is the seed scenario.
The seed scenario.
Yeah.
Right.
The idea here is that Sagittarius A started out as a much smaller black hole.
Okay.
maybe formed from the collapse of a massive star early in the Milky Way's history.
Okay.
And then, over billions of years, this seed black hole would have grown by swallowing up gas, dust, and even other black holes.
Okay.
And eventually, it would have become the supermassive black hole we see today.
So like the classic rags to riches story.
Yeah, you could say that.
Starts small and works its way up.
Exactly.
But there's some issues with this theory, right?
Right. To grow to its current size, Sagittarius A would have needed a constant supply of fuel.
Yeah.
And it's not really clear if the conditions in the early universe were right for that kind of rapid growth.
Right, like trying to figure out how a little sapling grew into this giant redwood tree.
Exactly.
It's possible, but we're missing some details.
Exactly. And that's where some of these other theories come in. Another interesting one is the direct collapse scenario.
The direct collapse scenario.
Yeah. So in this model, you've got this massive cloud of gas and dust, millions of times the mass of the sun, and it collapses directly into a black hole. It completely skips the whole star formation process.
That's pretty dramatic.
It is.
But wouldn't that create a lot of, like, chaos?
It would.
Would we be able to see evidence of that today?
That's a great question. And it's one of the big debates about this theory. The early universe was a crazy place, so it's possible. But we haven't seen any direct evidence of it happening, so for now, it's just a theory.
So the jury's still out on that one.
Yeah.
Are there any other possible explanations?
Well, another one, though it's not as popular, is that Sagittarius A formed from a bunch of smaller black holes merging together. So you can imagine this cosmic mosh pit of black holes colliding and combining over billions of years.
A cosmic mosh pit.
Yeah.
I love it.
Until you get the supermassive monster that we see today.
But wouldn't all that chaos leave behind some kind of evidence?
You'd think so, right?
Yeah.
And we do see evidence of black hole mergers in other galaxies,
Okay.
but it's not clear if that process could explain something as massive as Sagittarius A.
Right.
The galactic center is pretty crowded,
Yeah.
and it's possible that all the stars and other objects could have disrupted that whole merger process.
So it seems like we're still trying to figure out exactly how Sagittarius A came to be.
We are?
But one thing's for sure. It's had a huge impact on shaping the Milky Way.
Absolutely. As we learn more about Sagittarius A, we're not just learning about one object. We're learning about how galaxies evolve, the nature of gravity, and maybe even the fundamental laws of physics.
It's amazing that something so mysterious can teach us so much about the universe.
It is. And that journey of discovery is full of incredible wonders and tantalizing mysteries.
And speaking of mysteries, I think it's time we look to the future. What are some of the upcoming advancements that could revolutionize our understanding of Sagittarius A?
Well, one of the most exciting things is the next generation of telescopes.
Oh, yeah.
Yeah. They're going to be so much more powerful and sensitive
Right.
than anything we have today. So we'll be able to see even deeper into the heart of our galaxy and get even more precise data about Sagittarius A.
It's like getting a major upgrade to our cosmic lenses.
Exactly.
What are some of these telescopes that astronomers are really excited about?
Well, one that I'm really excited about is the Extremely Large Telescope, or ELT.
ELT.
Yeah.
Okay.
It's being built right now in Chile,
Wow.
and it's going to have this massive mirror over 39 meters in diameter.
That's like the size of a football field.
It is. It'll be the biggest optical near-infrared telescope in the world.
That's incredible.
Yeah.
What will that kind of power allow us to see?
Well, it's going to be able to resolve individual stars
Wow.
in the galactic center, even though it's super crowded.
Right.
So it's going to be like having a front row seat
Yeah.
to the cosmic ballet
I love it.
happening around the Sagittarius A.
What about those other wavelengths we've been talking about, like radio and X-ray?
Oh, yeah.
Are there any new telescopes coming online that will give us a better view with those?
Yeah, definitely. So in radio astronomy, we have the Square Kilometre Array,
Okay.
or SKA.
The SKA. Okay.
It's going to be the largest and most sensitive radio telescope ever built.
Really?
Yeah, it's spread out across multiple continents,
Wow.
and it combines signals from thousands of antennas to create this virtual telescope with incredible resolution.
It's like a truly global effort
It is.
to explore the universe.
Yeah.
So what kind of insights are they hoping to get from the SKA?
Well, it's going to be able to study those radio emissions from Sagittarius A in such detail
Yeah.
that we'll see the structure and dynamics of that gas swirling around it.
Wow.
And it'll also be able to probe those magnetic fields
Right.
threading through the galactic center.
Which we talked about earlier.
Yes.
Yeah, it could be regulating its activity.
Exactly. Exactly.
So the SKA will be like a cosmic detective, trying to figure out why Sagittarius A is so quiet.
Exactly.
Okay, what about X-ray telescopes? Any exciting new missions in development?
Yeah, definitely. So one that's coming up is the Athena X-ray Observatory.
Athena?
Yeah.
Okay.
It's a collaboration between the European Space Agency and NASA,
Oh, wow.
and it's going to be the largest and most sensitive X-ray telescope ever launched.
Really?
Yeah, it's going to be amazing for studying that superheated gas
Right.
and energetic particles around Sagittarius A.
So we're sending a high-powered microscope to the Galactic Center
We are.
to look at all the tiny details around the black hole.
Exactly.
That's amazing.
It is.
With all these new telescopes coming online, astronomers are going to have so much data to analyze.
Yeah, they
How
are.
are they going to make sense of it all?
Well, analyzing all that data is going to require some pretty sophisticated tools and modeling techniques. But the good news is that the field of astroinformatics,
Astroinformatics.
yeah, it's basically using computers to analyze astronomical data.
Right.
That field is growing really quickly.
Okay.
And they're coming up with new algorithms and software
Yeah.
to help astronomers understand these huge cosmic data sets.
It's like building a cosmic supercomputer to decode the secrets of the universe.
It is.
But even with all this incredible technology, it's important to remember the human element of all of this.
Absolutely.
What role will astronomers play in this new era of discovery?
Well, human ingenuity and creativity are going to be more important than ever before.
Right.
Technology is just a tool.
Yeah.
It gives us data,
Yeah.
but it's up to astronomers to ask the right questions, design the experiments,
Right.
and interpret the results. It's a collaboration between human intellect and machine power.
Like a beautiful cosmic duet, harmonizing to create this symphony of understanding.
I like that.
So with all these advancements on the horizon, what are astronomers most excited to learn about Sagittarius A?
Well, one of the big ones is understanding how it feeds.
Yeah.
How does matter actually fall into Sagittarius A? What are the mechanisms that control its appetite?
Right.
And why is it so much quieter compared to other supermassive black holes?
It's like trying to figure out the secrets of a picky eater.
Yeah,
Or maybe one that's always on a diet.
exactly.
We also want to know if Sagittarius A could ever have those powerful jets of energy
Oh, yeah.
that we see in other black holes.
Yeah,
It's quiet now, but could it wake up someday
it could.
and spew out jets that could change the whole galactic center?
Exactly.
It's kind of like living next to a volcano and wondering if and when it's going to erupt.
Yeah, it is.
But beyond its activity, what are some other fundamental mysteries that scientists want to solve?
Well, maybe the most profound question is what's the nature of the singularity itself?
The singularity.
Yeah, what's at the very heart of this black hole?
Right.
Is it really a point of infinite density?
Yeah.
Or is it something else, something we can't even imagine yet?
It's like staring into the abyss,
It is.
trying to understand something that's completely beyond our comprehension.
Yeah.
But even with all these mysteries that we still haven't solved,
Mm.
one thing's clear. Sagittarius A is just this incredible source of scientific discovery.
Absolutely.
It reminds us how much we still don't know about the universe,
Right.
and that the quest to understand it is full of wonder and excitement,
Exactly.
and it pushes us to the very limits of human knowledge.
It does.
Well, that brings our deep dive into the mysteries of Sagittarius A to a close.
Yeah.
We've traveled to the heart of our galaxy, explored the mind-boggling nature of black holes, and looked ahead at the future of cosmic exploration.
We have.
I hope you've enjoyed this adventure as much as we have.
I know I have. It's been a fascinating journey.
If you're as fascinated by the cosmos as we are, be sure to follow and subscribe to Cosmos in a Pod for more explorations of the universe. And don't forget to check out our YouTube channel
Please.
for even more amazing content. Until next time, keep looking up and keep wondering.